Hello, today we are doing 7-7 exponential growth and decay. First thing I want to do is a little bit of review looking at what kinds of equations we get from what kinds of sentences. So what situations would give us linear versus exponential equations. So if you want to try it on your own, pause the video, give it a try, and then I'm going to go ahead and do it. So pause now. Okay, let's go. So a person begins with $100 and earns $2 per day. A person begins with $2 and earns $100 a day. A person begins with $100 and each day the money doubles. So if you start with $100 and you get $2 each day, that's adding the same amount each day. So that's going to be linear, right? Adding the same amount each day is linear. So you're going to have the amount you begin with, and then the amount that you add each day is what goes with the x. Hopefully we remember this from when we learned y equals mx plus b, because that's essentially what this is. It's exactly what this is. So this would be the amount that you're adding each day is your m, right? So y equals mx plus b. So this is going to be the first one. And then if I start with 2 and I'm adding 100 each day, that's going to be this one. And then if I begin with 100 and it doubles each day, right? That's the same as multiplying by 2 each day. That's what that means. And so that's going to be exponential. Every time you're multiplying by something each time, that's exponential. So that's going to be this one. The initial amount goes here. The amount you multiply by goes here. Okay, so this one goes with that one. So hopefully that's all very familiar. All right, so I'm going to erase this so we can move on. And let's talk about some vocabulary. So I want to talk about compound interest. So first of all, what compound interest, well, interest in general, right? If you just have an amount of money in a bank account, so you have $100 in a bank account, say this is an extremely good bank account and you get 12% interest per year. That's really high interest, but I just chose it for easy math later. Okay, so say you get 12% interest per year, you have $100 in the bank account. So if you just have simple interest, then at the end of the year, you just get $12 in interest, right? Because 12% of 100 is just 12. So you would just get 12% interest. So at the end of the year, you'd have $112. If, however, you have compound interest, say you have, say your interest is compounding monthly, you still have an annual interest of 12%, but it's compounding every month. So instead of getting 12% at the end of the year, you're getting a 12th of that each month. So 12 divided by 12 is 1. So you'd be getting 1% every month. So instead of getting 12 at the end, you're going to get 1 every month. So say at the end of the first month, you had $100. The end of the first month, you're going to get $1, 1%, right? You're going to get $1. And so then you have $101. So then at the end of the second month, you're going to get 1% of 101 or 1.01, right? So now you have $102.01. And then at the end of month 2, you're going to get 1% of that. So you're going to get $1.02. And it's just going to keep going like this. So instead of getting $12 at the end of the year, you're getting 1% each month. But instead of just getting 1% of the principal, you're getting 1% of the principal plus whatever interest you've already gotten. So you're getting interest on interest, which is why it's called compound interest. You're getting interest on top of interest. So you actually end up getting more money that way than if you just got the 12% at the end of the year. All right, so that's basically what compound interest is. Hopefully that makes a little bit of sense. I'll try to explain more kind of as we go with some examples, but that's the main idea behind compound interest. Let's look at these words and see if we make sure we know what they mean. So the amount of money deposited in an account is the principal. So in terms of the equations we've been using, right, that's going to be our initial amount. The principal is going to be our initial amount because that's the amount you start with in your bank account. The amount of money earned on the investment only is going to be simple interest because that's where I just get interest once at the end of the year, right? So that's simple interest. I'm not getting interest on interest. I'm just getting interest on the principal. So that's simple interest. Interest earned on both the principal and interest. So I've already gotten some interest and I'm getting interest on interest as well as the principal. That's going to be compound interest. Okay. So simple interest is just interest on the principal. Compound interest is interest on the principal and interest that I've already gotten. And again, the principal is just the initial amount that I started with in my bank account. That doesn't include interest. It's the money in my bank account that's not interest. Okay. So, gotta erase this. All right. So let's pick apart this word problem. So Suzanne deposits $1,200 into a bank account paying 1.25% interest compounded annually for 5 years, at which point the account holds $1,276.90. So the principal is the amount that she started with. So she started with $1,200. So that's the principal. The interest rate is 1.25%, but if we were going to put that in an equation, that would be 0.025. I left out the 1. 0.0125, right? 0.0125. So if I was going to use this in an equation, I would need to use it in decimal form. The time in years is going to be 5 because we were told it was 5 years. And the final balance, the balance is the final amount. So that's going to be that. So if I wanted to put this into an equation, I could say my new balance is going to equal my initial balance times 1 plus my decimal, 1 plus my rate. We talked about that in the last section. We always have to add 1. And if you want to remember why I derived the reason for that in the last section, and that's going to be to the power of 5. The power is always going to be the number of times the thing has occurred. So we've gotten interest 5 times. So this is going to be 5. Yeah. So if you think of this not just as years, but as the number of times the whatever's happening in the word problem, this is the number of times that thing has happened. So in this case, it's the number of times we've gotten interest. And so that would be 5 years because it's compounded annually. So we get interest once a year. It's been 5 years. So the exponent here is 5. If you want to check that all this works, you could put this in a calculator and see if you get this number. All right. In the next video, we're going to do some a little bit more terminology and maybe some examples. So I will see you guys in the next video.